PQRS is a parallelogram in which PQ is equal to U, PS is equal to V. PQ is equal to U and PS is equal to V. It is noteworthy that the figure that we have here is a parallelogram. This makes life easier for us because the vector that we have here that goes from P to Q is U. Therefore, the vector from S to R will also be U. P to S is V because this figure is a parallelogram. The vector from Q to R will also be equal to V. We need to find an expression for QS. This information is given to us. Not all of it might be relevant in this case, maybe for subsequent questions, but let us take a look at it. M is the midpoint of QS. M is the point on QS such that QM to MS is equal to the ratio 1 to 2. The ratio QM to MS is 1 to 2. So this is one part in the ratio, and the rest of it, this, will be two parts in the ratio. Some students generally get this wrong because of the 1 to 2 or the 2 to 1 ratio. Students are always thinking 2. But we have to think 3 because this section is one part and the other section is two parts. That means the entire thing is divided into 3 parts. We have to think in thirds, 1/3 and 2/3. We will go straight ahead and write in terms of U and V an expression for QS, which will not make use of the ratio immediately. Let's take a look at it. The vector QS goes in a straight line from Q to S. The vector goes from Q to S in a straight line. That is the vector QS. However, we need the expression in terms of U and V. Therefore, we will have to take a path that includes the vector U and V. So let's go straight ahead. It is, in terms of U and V, the path from Q to S can involve those vectors, the vector U and the vector V. Let's go. Those vectors are the ones that we are speaking specifically of. Now, for the first part of QS, we will go from Q to P. So we go from Q to P, then we'll go from P to S. And that will be the same movement as from Q to S. The first part of the motion is opposite to the direction of U. This is U, and the first part of the motion is opposite to the direction of U. Therefore, we will consider that that part of the motion is negative U, going in the opposite direction of U. The other one is more to our suit because it goes in the exact same direction of V. Therefore, that direction or that movement is positive V. The second part of the motion is in the direction of V. We therefore have positive V. We prefer to write the vector with the positive vector first. So we have QS is equal to negative U plus V. We prefer to write it with the V first because it is positive. Mathematicians generally like to write expressions with the positive term first, if possible, rather than having an expression begin with a negative term. And that's all there is to it. QS is equal to V minus you. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.